Scene 1. Tornado Basics. To understand how tornadoes behave in cities, we first need to know how they form. Tornadoes are rotating columns of air that extend from the base of a thunderstorm to the ground. They're powered by a combination of wind shear, moisture, and instability, ingredients that come together inside massive supercells. Most tornadoes form in open rural areas because there's simply more space for thunderstorms to develop undisturbed. But when these violent systems move toward populated regions, the results can be catastrophic. Scene 2. Do cities affect tornado formation? One common myth says that cities somehow repel tornadoes. People often believe large urban areas create air turbulence or heat islands that disrupt tornado paths. But scientifically, that's not true. Urban heat islands, areas where cities trap more heat, can slightly alter local wind patterns, but not enough to deflect a supercell. Tornadoes are guided by massive atmospheric dynamics stretching tens of miles across. A few skyscrapers or warm roads can't stop something that powerful. In fact, cities like Dallas, Oklahoma City, and Nashville have all been directly hit by tornadoes in recent years. So, the idea that cities are safe zones is a dangerous misconception. Scene 3. The urban terrain effect. When a tornado actually enters a city, that's when things get interesting. The urban landscape, full of tall buildings, narrow streets, and varying elevations, interacts with the storm's airflow in complex ways. Cities tend to disrupt the lower layers of the tornado's circulation. Buildings cause turbulence that can either weaken the funnel near the surface or split it into multiple smaller vortices. In some cases, this can reduce overall damage intensity in certain spots, but it can also make destruction more unpredictable. Wind tunnels created by streets and skyscrapers can amplify local wind speeds, turning debris into high-velocity projectiles. So while the tornado might slightly weaken structurally, its chaotic winds can cause even more localized damage. Scene 4. Notable tornado strikes on cities. Let's look at some real examples. 1. The 1999 Oklahoma City tornado. One of the most powerful tornadoes in recorded history struck Oklahoma City, registering as an F5 with winds over 300 miles per hour. It caused massive destruction through suburban neighborhoods, proving that urban areas are just as vulnerable as open plains. 2. The 2011 Joplin, Missouri tornado. When this EF5 tornado hit Joplin, it destroyed over 7,000 homes and businesses, killing 161 people. The city's grid-like street system and large commercial zones actually funneled the winds, increasing the damage in some areas. 3. The 2020 Nashville tornado. This EF3 tornado tore through downtown Nashville late at night, damaging dozens of historic buildings. Surveillance footage showed debris spiraling between skyscrapers, demonstrating how urban structures can redirect tornado winds like massive blades. Each of these events shows a different aspect of how tornadoes behave in developed areas, and how city planning plays a role in the destruction that follows. Scene 5. The skyscraper myth. Another misconception is that tall skyscrapers can block tornadoes, but the average tornado is far taller than even the tallest buildings. For perspective, the Empire State Building is about 1,454 feet tall. Many tornadoes stretch several thousand feet into the air, some up to 10 miles tall within their parent storm systems. So no, skyscrapers can't block or cut a tornado. In fact, wind shear around tall buildings can enhance rotation in small areas, potentially intensifying the storm's effects on nearby structures. However, modern skyscrapers are often designed with reinforced steel frameworks that can resist extreme winds far better than smaller structures. So while damage is possible, total Scene 6, the role of building materials. One reason urban tornado damage looks so catastrophic is the variety of construction materials. Suburban homes built with wood frames are far more vulnerable than steel-reinforced office buildings. When a tornado passes through a residential area, it finds plenty of lightweight material to rip apart. Wood, shingles, glass, and metal sheets, all of which become deadly projectiles. These fragments can then smash into commercial districts, amplifying destruction. On the other hand, in central business districts with stronger structures, tornadoes often cause more superficial damage, shattered windows, roof damage, or collapsed facades, but not complete structural failure. So, in a strange way, the urban mix of weak and strong materials creates a mosaic of destruction, where one block is leveled and the next stands mostly intact. Scene 7. Tornado debris and secondary hazards. Tornadoes in cities also introduce unique dangers not seen in rural areas. When the funnel rips through urban infrastructure, it can rupture gas lines, ignite fires, and scatter toxic materials. Collapsed power lines and broken water mains add to the chaos, creating dangerous post-storm environments. For example, during the Joplin tornado, multiple hospital buildings were struck, leading to mass evacuations. And in Nashville, electrical fires erupted across several blocks immediately after the storm passed. Urban debris also complicates rescue operations. Narrow streets, fallen signs, and flipped vehicles make it hard for emergency crews to navigate. The recovery phase can take weeks, or even months. Scene 8. Do tornadoes slow down in cities? Another question often asked, do tornadoes slow down once they hit a city? The short answer, not really. Tornado speed is determined by the parent thunderstorm's forward motion, not by what's on the ground. However, local turbulence and surface friction caused by buildings can slightly disrupt the lower circulation, causing temporary fluctuations in intensity. Sometimes, this makes the tornado appear to hop or lift briefly, skipping over parts of the city before touching down again. But the storm's overall path and speed remain mostly unchanged. Scene 9. Engineering and mitigation efforts. As our understanding of tornado behavior improves, cities are adapting. Engineers now study how buildings interact with rotating wind fields to design safer structures. Modern building codes in tornado-prone states like Oklahoma and Kansas require reinforced roofing and impact-resistant windows. Newer public buildings, such as schools and hospitals, often include dedicated storm shelters built into the design. Urban planners are also identifying evacuation routes and safe zones to minimize casualties when disaster strikes. And with the rise of radar and satellite technology, early warning systems are faster and more accurate than ever before, giving city residents precious extra minutes to seek shelter. Scene 10. The future of urban tornado. Researchers are still learning how tornadoes evolve as they move through complex terrain. With high-resolution computer simulations, scientists can now model how airflow interacts with buildings, trees, and even bridges. These models reveal how tornado intensity changes block by block. The goal isn't just to predict paths, it's to understand how to build cities that can withstand them. From aerodynamic building shapes to smart early warning systems, the next generation of urban design may literally learn from tornadoes themselves. Tornadoes don't discriminate between open plains and busy streets. Whether they're tearing through farmland or downtown high-rises, the forces at play remain the same: chaotic, powerful, and awe-inspiring. What changes is how we prepare for them. Cities might never be able to stop a tornado, but through smart design and scientific understanding, we can learn to survive them and rebuild stronger than before. If you found this video fascinating, make sure to like, subscribe, and turn on notifications for more deep dive explanations just like this.